Hi everyone, this week we'll be talking about memory forensics. I will try to give you guys an introduction to the field, and if you are interested to explore further, you can refer to the book The Art of Memory Forensics by Michael Hale. The objective of this lecture or lectures are to give you guys like a brief introduction of memory forensic, see what type of different evidence we can recover from the memory, how to perform the memory analysis, and the tools and techniques used to do the memory forensics. So in a computer system, there are multiple locations from which you can recover the evidence. Files or deleted files are one aspect. And as you guys have already performed this operation in lab 2, you try to see the deleted files. Window registry is another location from which you can recover the data. Log files, another thing, trace network traces. You can see like the IP addresses your computer is connected to. They all are in the network traces. You can also look at the browser cache to see what the user is doing, like what websites the user is trying to, connect to. Similarly, print spool files are like all the printer files that the documents that you send to printer, they go to print spool files. So you can recover them as well from there. Another aspect or another important location is the random access memory or RAM of your computer. Why it is important? Because the RAM of the computer contains OS and user data, like applications data structures. So all the programs that you run on your PC, they reside inside the RAM. So that's why it contains a lot of important information that we need to recover in memory forensics. Now let's come to the definition of the memory forensics, that what is the memory forensics. So memory forensics or is like refer to the examination and analysis of volatile data in the computer's memory dump. So whenever in this course we say memory dump, we are referring to a snapshot or say a dump of the RAM of the computer. And memory forensic is the examination and analysis of the RAM of the computer, like what's inside the RAM of the computer. The next question is why memory forensics? Like, why do we need to like investigate or see what's inside the memory or what's inside the RAM? So to answer that question, the idea is that there are so many different aspects or so many different things, forensic artifacts for a case that only reside in RAM. For example, when you are using your computer, you turn on or you launch Google Chrome and you start browsing or and going to different websites. So when you enter any URL on the Google Chrome, at the back end, that URL is translated to an IP address, and your computer creates a connection to that IP address, and like to whatever server is hosted on that IP address, and then you start communicating. So as soon as you close that thing, you close the Google Chrome, that connection will be stopped, and that data will be removed from the memory. So all the things that a user does during any session or any interaction with with the internet, or if you are writing something in Microsoft Word, or you are browsing the websites on the internet and so on, everything, all of this information will reside inside the RAM. Another thing is, for example, if you guys are using any password protection or any encryption on a file, like you have a special tool, a special software that encrypts the files that you work on. So the passwords or other information that you use to encrypt your files, they will also reside inside the RAM, because every time you open that software, you will enter your password in that, and that information will be stored inside the RAM. The next thing is what data can be retrieved from the RAM, like what are the different things that we can recover. So a memory dump is a snapshot or a capture of the computer data at any specific time. So just like you guys did in your lab too, you took a snapshot using FTK imager. So whatever you were doing during that particular time when you took the snapshot, when you took the memory image, for example, if you were browsing the internet, if you had some open applications that were running, if you were working on Microsoft Word, you typed something like incomplete text on a file, everything will be inside the RAM. And when you take the memory dump, all of that data will be stored in that memory dump. So if you examine that memory dump, you will be able to find different things such as the different network connections that your computer might have created, with other devices on the internet, all the recently executed commands. So every time you put a command on command line, you run it, that command is logged inside the memory, and that you can find from there. Similarly, account details, credentials, like your encryption, decryption keys, your passwords, those type of things, they are all inside the RAM as well. Similarly, if you are using some chat messages, say like Facebook Messenger or some other messenger, you are running that application on your PC, your messages that you have sent, and the other data about that particular process, that will also be found in the RAM. Similarly, you can also find credit card numbers, financial data, medical records, these type of things in RAM if any application uses them and it is running while the memory was captured. Now, a question might come in your mind that why all this data is inside the RAM, right? Why not hard drive? Because we have a lot of space over the hard drive. Why don't all these processes store this information on the hard drive? The answer to that is, first is the performance needs. So a RAM or a random access memory is way faster than a hard drive. So in order to run an application smoothly, what happens is the application pulls out all of its data. For example, when you double click on application and launch it, it pulls out its data, like its executable and other things, and put them inside the memory. So it is like, since the RAM is faster, like you can recover or read and write the data faster through RAM. So all of your applications, they store their temporary data inside the RAM as compared to storing that inside the hard drive. Another example that you guys might have seen is, like, for example, when you are doing typing some file or creating a text file on Microsoft Word. If you try to close the Microsoft Word, it will ask you whether you want to save this data on the file or not. So what it actually asks you is whatever you have written, that text that you have written, it is stored in RAM. And when you say yes, store this data, then Microsoft Word will create a file on your hard drive and store whatever you were doing on that particular file on your hard drive. Otherwise, that data still stays in your RAM unless you save it or unless you cancel. So the first is performance, because of like the RAM is way faster. Reading, writing is reading and writing happens in less time. So all these applications, in order to increase their performance, they store their temporary data inside the RAM. The other thing is, like, a lot of application designers, since they know that RAM is faster, they have designed their application in a way that they use more like the storage in RAM as compared to the storage in the other, like a hard drive or something else. So since all this, like, programs, they use the RAM to store their temporary data, sometimes if the application is not properly closed, the data of that application will still stay in the RAM. So for example, like you were doing you opened a banking application and you put your credentials inside that application. But when you close the application, it is not properly closed, or there is some malfunctioning in the application. But since you ran it on your PC, that data will be somewhere residing in the RAM. And unless it is wiped out by some other process or the operating system, or that thing is like, you open that application again and it overwrites the data, that will still stay there. Lastly, like most of the users, like when we use computer, we don't care, like, where our data is going, whether it's in the RAM or whether it's in the storage. So most of the times the user are unaware of this data residing in RAM, and it will stay there unless it is overwritten. So because of these issues, like, first is performance issue, then the applications are developed in a way that they use RAM more because it is fast. The other thing is, like, if the application is not properly closed, or if the application is malfunctioning, its data will still reside in the RAM. And lastly, the users, they are unaware of all these things, all the data that might be residing in the RAM. That's why if you capture the RAM or the memory, take a memory dump from a suspect PC, it might contain a lot of information, as we discussed earlier, like network connections, open, running processes, credentials, passwords, encryption keys, and so on. So given all this information, what our goal is for doing the memory forensics is to understand that what is happening inside a computer and who is doing what. So for example, we want to see, like, if we capture the memory, we want to reconstruct the web session or say internet session, and see which different websites the user was communicating, what different websites the user opened in his web browser, and so on. Similarly, we want to see, like, we want to find files. So if there was like any files that was accessed remotely, like downloaded, edited, those type of things, we want to find that or identify those files. We want to find the passwords or encryption or decryption keys, credentials for others, say like credit card credentials and so on. They might also be present in RAM, so we want to discover them. And lastly, we want to identify remote machines from network connections. So like if we examine the network connections, we will be able to see all the devices or all the other, entities on the network that this device was communicating with. So since all of this information is in RAM, we want to reconstruct the whole, you can say, session, and see what the user was doing at the moment we like captured this memory, or we captured this memory forensics image. So, given the importance of memory forensics and the different types of data that we can find from the memory, let's talk about the memory forensics workflow and see how the whole process happens, like what you need to do in order to do or in order to perform a successful memory analysis. So, the first thing to do here is similar to the, static analysis that we did for the other thing. You need to have like a copy or, like a dump of the memory. So the first step is capture the RAM from live system. So while the system is running, we need to make a dump or we need to make a copy of the system's RAM. There are different ways in which you can, like make a copy. If you are investigating a physical PC, you have access to the physical PC, you can use softwares like FTK Imager and take the snapshot of the RAM at that given time. Similarly, on the other hand, if the device or the say system that you are examining is a virtual machine, then for those guys who have used virtual machine, you would see like in virtual machine you have the option, all the hypervisors, whether VMware or VirtualBox or whatever you are using, they provide you an option to take a snapshot. So a snapshot is basically when you take a snapshot, just like as you take a picture in real world, it saves everything, all the things at that particular moment. A snapshot saves everything that you are doing in that particular moment. So for example, whenever you take or press the snapshot button on your virtual machine, whatever was happening in the RAM, it takes a copy or makes a dump of all of those zeros and ones that are in your RAM. The third thing or the third technique is virtual machine introspection. So virtual machine introspection is basically a technique in which you can inspect a virtual machine running on a hypervisor from outside the hypervisor. So ideally, all these virtual machines, they are supposed to be isolated. They need to, run separately from a host. And even like if two virtual machines are running, there shouldn't be any overlap or any, connections between those two virtual machines. The data in each virtual machine is like isolated and separate. But virtual machine introspection provides you the ability to see what is happening inside a virtual machine from outside the system. So say your hypervisor that you're using, if you have, the capability to introspect the virtual machine, you can see like what processes are running in the virtual machine, what network connection the virtual machine is making, what files are open, and so on. So these are like the three different things or the three different ways in which you can, capture the data from or capture the RAM from the PC. If it is physical PC, just use tools like FTK Imager, take the dump. If it is a virtual PC or virtual machine, you can use the snapshot or virtual memory introspection. Then once you have this, the memory dump, then the next part is analyzing the memory dump. Here you have different techniques and different tools that you can use. So strings is one command. So what strings does is basically the memory that you capture. It's like, a bunch of zeros and ones. So 4 GBs of zeros and ones. So strings tries to convert those zeros and ones into alphabetical strings that you can read. So if you press string command and give it a memory dump, it will give you a list of all the strings that it found within that memory dump. So now how it is useful. So for example, you are, like trying to figure out about the password or username that I might be using, right? So you take the memory dump of my PC or my laptop, and then you know that my name is Syed Ali Qasim. So there will be, if you type or try to find Syed Ali Qasim, you might find my username or you might find my password within that memory dump. So strings will basically just convert all the zeros and ones into human readable strings, and you can search them in a similar way you search for any word on say Microsoft Word or something else. You press Control F and you can, like search for any word. Similarly in strings, you can search for any string or any word within the memory. The next thing or the next technique is called data carving. So this is similar to strings. So data carving is basically your RAM is a bunch of zeros and ones. So if you just look at those zeros and ones, like without any knowledge, you will not be able to understand. You will not be able to see any data structure. You will not be able to see any process, any object, and so on. So data carving is a technique in which, like, for known signatures for different applications. For example, if we know that, if a file like all the Microsoft Word files, they always start with a signature of 0 1 0 0 0 1 0 0. So in data carving, we will try to see if we are able to find the sequence inside the memory, and then try to carve, or extract that file out of the memory. So given the known information about different files and their data structures and different applications and their data structures, we are trying to figure out or carve or extract those data structures or those, like objects from the computer's memory. The next tool that we will be using is volatility. So volatility is a command line tool which kind of, provides you the ability to carve the data. It has like a lot of plugins or say, like different sub programs that you can use in order to get a lot of information about the processes, the network connection, the commands, the files, the DLLs and the handles and so on, like all the things that are going, all the data structure objects that are inside the RAM, you can extract them or carve them using volatility. So with the help of these tools, our goal is to expose the operating system and application structures. So everything inside the RAM is in the form of a data structure. So all the applications that you run, they have like a specific data structure which is called e-process. So they like, like your Microsoft Word, Google Chrome, everything is in the form of e-process data structure in RAM. So you can extract them using volatility. You can see like who started this project, this process, at what time this process was launched, what different type of data does this process contains, and so on. So our goal is to, using volatility and using strings, data carving techniques, we want to extract as much knowledge about the session or as much knowledge about the different things that were happening inside the PC as possible. Now let's talk about the acquisition decision tree. So, like sometimes you are not sure, you go to a case, sometimes you find a physical machine, sometimes you find a virtual machine. So what are the different steps or what are the different, things that you need to be aware of for data acquisition or for RAM acquisition? So the first thing is to just, like look at is if the data or the machine from which you want to get the memory or acquire or take the memory dump, if it is a virtual machine, then our job is easy. We can just, use like take the snapshot. We can pause the machine, take the snapshot, we can clone it, we can do the disk cloning, virtual machine introspection. All of these things are like mostly provided by the hypervisors such as VMware or VirtualBox or any other hypervisor that you're using. So like you can use these utilities and perform the data acquisition. If the machine from which you want to acquire the data is not a virtual machine and it is like a physical machine, then you have to look whether it is running or not. Why? Because if it is not running, then like the whole purpose of acquiring the RAM is almost gone. Because since RAM is a volatile memory, if the PC is turned off, no matter what information was stored there, now it's gone. But even in that case, there are a couple of things that we can find. First are the hibernation files. So whenever you hibernate your PC, basically you are telling your PC to, save the whole session, and the next time I come out of the hibernation or I start resume my PC again or restart, like, start my PC or laptop again, I need the operating system to recreate the whole session that I was working on. So what the operating system does is when you go into hibernation, it kind of takes a snapshot of your RAM and it stores it on the hard drive. Then after that, when you come out of the hibernation, it pulls that hibernation files from the hard drive and populate the RAM or put that data inside the RAM in order to give you the same session that you were using. Like all the applications that you were using, they will all be there. So these hibernation files, since they are stored on the hard drive, so if the PC is not running, you can look for the hibernation files on the hard drive. Similarly, page files are another component that you can figure out or that you can find on the hard drive. So what happens is like all the application that you run, they like need some certain amount of memory or some certain amount of RAM. So suppose you were like running 10 different applications and they consume all of your memory and you are running out of RAM or free memory. What will happen in that stage is your operating system will look at the applications that are running but not that much use, like they are in idle condition, you are not using them that much. For example, you have some open application that's been open for the last 5 days on your PC. So your operating system, what it will do is that all the memory that it has given to that particular application, like all the data that that application has in RAM, it will store that data onto the hard drive in the form of page file. So whenever the next time, if you somehow go back to using that application that was idle for a long time, the operating system will pull these page files out of the hard drive and put them back on the memory and give you the same experience or the same session that you were working on. So both hibernation file and page files, these are like the part of the memory that are stored on the hard drive, given when the memory of when you are running out of the memory or when you want to hibernate or turn off your PC. The last thing are the crash dumps. So when you are using your PC and suddenly it crashes, the PC, the operating system on your PC, they create a crash dump, which is mainly like an information report about what went wrong. So sometimes most of you will have experienced that if a software crashes while you are doing something, after you restart the software, it asks you or it tells you that it crashed unexpectedly last time. Do you want to report the details to the software developers or not? So those details, they are stored in the form of crash dumps. So every time like a PC or a application crashes, it creates a crash dump and it stores the some particular information on the hard drive about what wrong happened or why did the program crash. So these three different type of files, like the hibernation file, the page files, and the crash dumps, they will be on your hard drive installed. They are like technically part of running applications or technically part of RAM. But because you are like turning off your PC, or because your PC is like going out of RAM, or like any application crashes unexpectedly, these information or these this data is stored on your hard drive that you can recover even if your PC is not running. So if the PC is running, then you have to look whether you have the root access or not. If you have the root access, then you can install softwares like FTK Imager on the PC and then just take the snapshot. If you don't have the root access, then there is only one way, which is using the hardware devices, or putting hardware probes on the physical PC. And that is like not we're not going to discuss that the hardware acquisition of the RAM in this course much, but just to give you guys an idea, you can either look at the PCI bus, or you can look at use the tools like Firewire in order to get the data, or like in order to get a physical memory dump using the hardware, or like by actually probing the hardware. So next, there are a couple of things that you need to be aware of when you are doing or when you are acquiring the memory using software-based acquisition approaches. The first thing is whether you should acquire the memory, like via remotely, or whether you should go physically to the machine and acquire the memory from there. So it depends on the location of the machine and what type of access you have. If like it is a remote server, like running on like a location far away from your location in a different city or in a different country, then you have the only option of acquiring the memory remotely. If you have physical access to the device, then you can go there and acquire the data physically or locally. So you can, bring your or take your USB drives, you can copy the data over there and bring the data back to your lab. The next thing is the cost and memory dump format. So most of the time, tools like FTK Imager are free, but a lot of the other tools in digital forensics, they are not free and they are proprietary. You have to pay and buy licenses for them. So depending on your, budgetary constraints, whether you can afford tools or not, you can go for the remote or the local acquisition. Similarly, if it is out of your budget to travel to a location far away just to collect the data, you can go or you can use remote acquisition methods in order to acquire the data. The next thing that you should be aware of is atomicity. So as I mentioned earlier in the lecture, all the programs that you run on your application or on your PC, all the application, including the operating system applications and processes, all of that runs or resides within the RAM of your system or within the RAM of your computer. So if you guys just open Task Manager, you can see like even in the idle situation when you're not doing anything at all on your PC, you will see that there is a lot of activity on the RAM that is happening in the background. So this is something that you should be aware of, that at any given time there will be a lot of activity going on the RAM. So that's why if you capture the like you saw this phenomenon in the lab as well, that you captured the RAM at two different instances, and you see that the two like copies of the two dumps that you created, their hashes were different. So their content changed over time because of all the processes that are happening in the background. So this is something you should be aware of when you are doing the acquisition, that even if you acquire the RAM or the memory dump from the same PC at two given times, there will be a definite change in the, the hashes or the all the data that is inside those memory dumps. Another thing that you this also like possesses another challenge, that if you are acquiring a memory say remotely, or you are using software like softwares like FTK Imager to acquire the memory or create the snapshot, those software tools like FTK Imager or the remote connection that you have created to that remote PC, they will also leave a footprint on the RAM. So all these things like the atomicity, it's continuously changing, and all the application or the applications you launch or the actions you perform, they will have an effect on the suspect's memory. So make sure to keep this thing in mind, that when you are like acquiring the data or when you are doing some memory analysis, there will be some footprint of your doing like your footprints as well. Like FTK Imager, you will find it inside the memory that you captured using the FTK Imager. The next thing is the device memory. So when you start or when you boot your process like PC, the BIOS it initially starts the whole operating system, and then it gives a physical memory map to the operating system. So basically, your RAM is divided into a different like subsections called pages. So the BIOS tells the operating system that here is the map of all the pages or all the locations inside a memory that you can use, and on that map some regions are marked as reserved. So reserved regions in a memory are dedicated for the operating system use, or say firmware used by various motherboard devices. So the BIOS tells the operating system by giving it the physical memory map that please stay away from these reserved regions. So if somehow you are acquiring the memory content or the RAM of a system, try to make sure that you don't mess up with the reserved regions. And also sometimes bad things can happen, so there is a chance that when you are acquiring the data, you mess up or you change something in the reserved regions, and that messes up or that disturbs the whole firmware, and your computer starts malfunctioning. So that is another thing, the risk of device memory regions or reserved regions that you need to be aware of when you are doing or acquiring the memory. So when you should acquire the memory, general suggestions. So you should acquire the memory, when there is nothing happening on the PC. Like try to make sure that during that acquisition process, you or like the user don't open any new applications on the PC, or like don't go on the internet, start browsing. Don't do those type of things. Try to make sure to have a very minimum footprint on the computer's RAM as possible during the time you are acquiring the data. Another thing is there are certain times in which you should avoid acquiring the memory. The first is the computer startup or shutdown. So when you start the PC or when you turn off your laptop or your PC, your operating system is like either pulling a lot of files during a startup. There are a lot of other operating system, kernel, BIOS, all those things, operations happening on the background. Similarly, when you shut down, there is a lot of activity by the operating system going on your RAM or on your memory. So during that times, during startup shutdown operations, try to not capture the memory because it will have a lot of footprint of the operating system. Another thing is when there is some kind of system maintenance happening, such as disk defragmentation, or like you are scanning for a virus, or there is a system or Windows upgrade, those type of things, or you are backing up data to some remote server. During these times as well, when there is a lot of activity happening in the background, try to avoid capturing the RAM, and capture the RAM where there when there is not so much background activity going on. The next thing, as I mentioned earlier, is limit your interaction with the machine while you are acquiring the memory. So when you press the take snapshot button on FTK Imager, don't do anything until it tells you that it has successfully captured the memory. And the whole idea behind this is to minimize your footprint on the suspect's memory as much as possible. So next is the process, how to acquire the memory locally. So this is the same process as we will do for acquiring, like a physical, like the data from the hard drive. The first thing is, just bring your own USBs or say external drives with which on which you want to store the data, and never dump memory to the target system's local drive. So, whatever you are like acquiring. So when you take the snapshot, using say FTK Imager, don't store that like snapshot on the system on which from which you are acquiring the data, or don't store it on suspect's drive. Rather, store that image or that the acquired memory dump on your own USB drives or on your own hard drives. Next thing is like for better performance, go for like when you format your hard drives or say USB drives, try to format them using the NTFS file system, because it is much faster and much like high performing as compared to the other ones. The other thing to keep in mind is don't connect the same media to two different PCs, because you never know, there might be some malware or some virus that you might have captured along with the data or the memory dump. So don't just plug and play same USB drive on multiple PCs. So when you acquire the memory or say data dump from one PC, take that USB or hard drive back to your lab, copy paste all the data on your PCs, and then you have to format the drive or the USB altogether, and then you can use that drive for other PCs as well. So that is called sterilization. That sterilize your like equipment, all the USB drives or hard drives that you're using. Make sure that they are just used for one PC, and then you like take the data back, make copies of it, and then like format it fully before plugging it into another PC or into another for another case as well. So when you are doing the remote acquisition, typically it is same as doing the remote acquisition for the hard drive, that you need to push a tool over the network to the target machine. So for example, if you are in Grand Rapids and you want to acquire the data from a PC that is running, say, in New York, then you need to have an internet connection. First of all, for both of these devices, they need to be connected to the internet. The next is you need to have some kind of software on the suspect machine in New York with which you can communicate. So Windows remote login is one such example, like you can remote login into that PC, and then from there you can start, like you can download FTK Imager or, any other tool, take the memory snapshot and then bring them back. So transfer those memory snapshots back to your PC remotely. Another thing to do is while you are making this connection, try to make sure that, like your PC or the suspect machine is not connected with or not communicating with any other entity except from you. So the idea is that, like try to block all the other internet connections except from yours, because you don't want anybody to, like do the same thing, log in or, send some file remotely to that machine and disrupt your whole process. And in cases, like if you are investigating a case, it is also possible that while you are performing this operation, the suspect transfers a malicious malware or say a virus on the machine, and it not only disrupts the whole machine, but when you are filing, like transferring that data back to your machine will also be infected with that virus. So try to block all the other connections to the target machine or to the suspect machine except yours while you are performing the remote acquisition. Now let's see the organization of the memory by examining the memory dump. So imagine the RAM in your computer is divided into numerous smaller chunks, each of size 4 KB. So these smaller chunks, they are called pages, and they are the basic building block of your entire memory. So your RAM will be a collection of like a lot of these smaller 4 KB pages combined together. Every page in the RAM is assigned a physical address, which is a unique identifier that marks its exact location within the RAM, like where in the RAM any particular given page resides, like its physical address. Now, when a process running on your PC needs memory, it requests these pages from the operating system. It's the job of the operating system to allocate these pages to the process. So the operating system will see at, like what pages are available, what are in use, what are reserved. As I mentioned in the previous, like there are some pages that are reserved for system use, for firmware use, and so on. So depending on how many pages are available and how many pages the software or the application needs, the operating system will assign these pages to the different applications that are running on your PC. But interestingly, the process doesn't interact with these pages using the physical addresses directly. Instead, it deals with what we call a virtual address. The virtual address provides a simplified and continuous view of the memory to each process, as if it is the only process running on the entire RAM or in the entire PC. So the idea is that each process will have its own continuous view. So for example, PC1 requests application one request for some certain amount of pages. The operating system will see which pages are available. So say one page in the beginning is available, then some page in the middle is available, and the last page in the end is available. So the operating system will assign these 3 pages to this particular application, but the application will think that these 3 pages, they are in a continuous form, like they are say, all in the beginning or all in the middle or all in the end. So to do that, the operating system will tell, or give the virtual numbers or the virtual addresses of these pages to the application that will be continuous in a very specific region of the memory. So when we take the memory dump, we not only, copy all the zeros and ones that are stored or that are like there on the RAM. We also copy this information, which we call the page table, which is actually the virtual versus the physical memory address mapping. So this part is also like, when you copy the RAM content, this is also included, the page memory that goes in your memory dump as well. Why it is important? Because when we are trying to figure out or like carve the data for each application, we want to see like what pages were used by say Microsoft Word, and we want to recover the file that was running on Microsoft Word. So in order to efficiently recover the file or recover the memory, we need to know, like from the Microsoft Word's perspective, it will be like page number 1 to page number 100, but physically those pages will be scattered all over the RAM physically on different locations. So we want to make sure that the 100 pages that are like associated or that were allocated to the Microsoft Word, where those pages are, so we can get or extract the data out of them. So this page table is an important component, or virtual to physical address mapping is an important concept that we need to know in order to better carve the data or extract the different data structures out of the memory. So what are the typical scenarios in which we will be using like memory analysis? So for all the cases when we want to see, like what was happening on the system, or we want to recreate the scenario, we will be looking into the memory forensics or the analysis of the RAM. So for example, if there is an ongoing crime which is in progress, like a server is running, distributing torrent files, or like there's another server that is distributing child porn or something like that. So whenever there is like some ongoing process that is happening, or you want to recreate that process, we will be using the RAM analysis or the memory analysis. Another thing is whenever we are doing say malware analysis or virus analysis. For example, you come up with a case where you find some explicit content on someone's PC, and the accused say that he didn't do it. There might be a virus or like a malware on his PC that stored that explicit content on his PC. So in those cases, we will be doing the malware like the memory analysis, and we will try to see whether there is some malicious program running on the PC or not, like whether he was really affected by some malware or virus, or he's lying. So in these type of cases, again, we can look into the memory analysis or the RAM analysis. So what type of information we can retrieve? So we can see like all the running processes. We can see the process trees, like, what are the different processes that are running. If a process spawns some other processes, for example, when you open Google Chrome and you open multiple tabs, there the Google Chrome, it will have one main process, and then that process will like generate or start multiple different process for each tab inside your computer. And you can see that, like if you use Google Chrome, just open the task manager and you will see a lot of different processes that are just being started, or that just they are connected with Google Chrome. Open files. So if you are working on say Microsoft Word and you are typing something, so unless you save that file on your hard drive, that file stays within your RAM. So that's something again that you can recover. Similarly, network connections are something else. So all the connections that you make when you are using the PC, or when you are like using the PC, like doing some work on your machine, you are like browsing the internet, like transferring files, you are emailing, all those things, the connections that you make, you will see their IP addresses and when the connection was made and so on. Similarly, we can, like get encrypted data information as well. So for example, if you use some particular software to encrypt the files, so when you open that software and enter your encryption key, so as long as that software is still running, the encryption key will be inside the RAM, inside the pages that are allocated for that particular encryption application or encryption process. Another thing is like, some other credit card information. If you're using a banking application, your credit card information or your username and login, they will be stored within that application as long as it is running. And lastly, you can also, find traces for malwares, for viruses, and those type of things within a system as well. So here's a comparison, or say a summarization of different things that you can find. So in Windows, open files, open network connection, registry activity, open DLLs. So DLLs are the window files that, like are used by different programs. So these you can also say drivers to some extent. So every program when it runs, it requires some basic functionalities from the operating system. So it opens some DLLs, get them from the operating system to perform correctly. In Unix, you have open files, open network connections, commands that you have invoked, environment variables that you are using, like the corresponding like exe or say applications. For example, whenever you open an application, there will be an executable for that, which is like your program that runs the application, and then there will be user data as well. So both of these things are present in memory for both cases, like the executable of our application as well as the user data, or the data that the user generates while he is using that particular application. So here is the user space and the kernel space overview. So as I mentioned earlier in the previous slide, that the memory is divided into different 4 kilobyte pages. So there is a component called memory management unit, or MMU. So it is the responsibility of the MMU to assign different pages to different applications, as well as the translation of virtual to physical addresses and so on. So the operating system, with the help of this MMU, memory management unit, does all that translation. Outside that, there are two different type of applications that run on your machine. The first are the kernel machines, the kernel applications, like the applications or the programs that are essential for running your operating system. They reside in the kernel virtual address space. And then you have the user virtual address space, where all the programs, say Google Chrome or Microsoft Word, or say Adobe Reader, or any other application that you open. So each of these applications will, request some pages from the OS, and OS, with the help of memory management unit, will allocate some pages to them. But the OS and the memory management unit, they will translate the physical address to the virtual address before passing those pages to different processors. So when you are doing the memory dump, you have two options. Either you can create a dump of this whole memory and you can start analyzing the whole memory, or you can, individually dump the memory of individual processes, or examine the memory of the individual processes. So this is called, like a process or user memory, or the kernel memory. So the process or user memory is more fine grained. For example, if your case involves Microsoft Word files, then you should only dump the memory of Microsoft Word and try to see if you can, like whatever data you can extract from it. It will be easier. It is easier to, like also translate the virtual address space to the physical address space, and vice versa, when you're just looking at one process. And it will also give you a continuous view. So if you look at the virtual address space, you will see a continuous set of pages that are assigned to the Microsoft Word document. Another thing or interesting thing is like, the password or other credentials that you use inside each individual application, they will reside inside the process memory of that particular application. So for example, if we are looking for the banking application and we are trying to figure out the username or the password of the that the user might have used, rather than investigating or trying to find that username and password in entire memory, we can just focus on the process memory of, say, Chase application or Bank of America application that the user was running, and try to see if we are able to extract some strings or some, like username or passwords out of that. Then in the kernel space, whenever you are investigating, say, malwares or viruses or trojans, those type of things, or in those cases, you will be looking at the kernel memory as well, because like your viruses, or say like the malwares, they try to hide themselves. So you have to look into the different kernel objects in order to find, the working or the existence of the different viruses or malwares on your machine. So there are three different tools that we will be, demoing in this, or will be using for the memory analysis. The first is the sys internal tools for Windows. So sys internal tools is, when you are doing live analysis, you go to the suspect machine, and over there, if it is a Windows machine, you can install or like download the sys internals for Windows, and it provides you a bunch of different functionalities. These are all different applications that come inside this is internal tool suite. And some important ones are like PS list, which will give you the detail of all the processes that are running on a machine. PS logged on, you will see like who logged on locally, or we are sharing as well on that particular device. Why these are important? For example, PS list, why it is important? When we are investigating malwares or viruses, most of the malwares or viruses, they try to hide themselves. So if you open Task Manager and try to see the applications that are running, most probably you will not be able to see the virus or the malware program running in Task Manager. It will try to hide itself. So for that, we, in order to do the, thorough analysis or an in-depth search of what different processes are running, we can use these tools or these like, applications like such as PS List, PS Info, and so on to do further analysis. So some other like handles or DLLs as well. So as I mentioned earlier, like the application in order to run it, loads or needs some DLLs from the operating system. So you can list down the DLLs that are used by each of the application and see whether whether the process actually need those DLLs or those resources in order to function or not, or whether it's exceeding its usability. Like it doesn't need some resource, but it is still requesting it. That means, or that can indicates that this process is trying to something trying to do something fishy. So at the end of the lecture, I will also, or maybe like in a separate video, I will try to give you guys a demo of how all these tools as well. So don't worry, this is only for lecture. We'll do the demo as well. So the next one is string. So as I mentioned earlier, your RAM is just a bunch of zeros and ones. So if you try to read the RAM, like, with naked eye, you will not be able to figure anything out. It will be just zeros and ones. So strings is a tool that you can give it any file, any bunch of zeros and ones, and it will try to extract, the ASCII keywords or the ASCII characters out of that memory dump. So using this tool, you will be able to see all the strings that are, present inside the RAM or inside the memory. So all those zeros and ones, it will try to convert them into human readable ASCII characters. Why it is important or how we can use it? For example, if you know me and say, my name is Sayed Ali Qasim, and you have the memory dump from my PC. So you can say that, I will be using Sayed Ali Qasim as username and, as password as well. So if you search Sayed Ali Qasim using strings in that memory dump, you will be able to find, or you might find my username or you might find my password if that includes this particular string. The next tool that we'll be using for memory analysis is volatility. It is developed by the Volatility Foundation. This is their web link. It is like I will also provide all this information along with a demo and a small activity for you guys in lab 3. So you will be doing the memory analysis in lab 3. So volatility is basically similar to system like sys internal tools. So sys internal tools run on a machine. They are used for live forensics, whereas volatility is used for static analysis. So you acquire the volatility like a memory dump, say take a snapshot or acquire it using FTK imager, no matter how you acquire, then you can analyze that memory dump using the volatility framework. So volatility framework consists of different plugins or different applications or say commands that you can run on any given memory dump. And these commands or these plugins are for different things. For example, viewing what processes were running. We can also see the open network ports, the open network connections. We can see what commands the user typed and so on. So there are a lot of like, say tens of different plugins that are available within the volatility, and it's up to you like how much in depth you want to go for memory analysis. So this is, like a way to install volatility for you guys. So just go on the volatilityfoundation.org, their website. Over there, go to releases, and there you can find standalone versions of the volatility as well. So you don't need to like install it. Just, download the standalone version. It is available for all 3 different operating systems, Windows, Linux, as well as Mac or iOS. So just download that, unzip it, and inside the folder, you will see a executable file called volatility standalone and the full name of the file. Just like, rename it to volatility so you can use it, efficiently. The other thing is like for those of you guys that will be using it on Linux, it requires, Python. So you need to install or you need to make sure that Python is installed on your PC before starting volatility. So there are 2 different versions or say, like of volatility. One are volatility like 2.6, 2.7, these things in the range of 2. And the next one is volatility 3. So there is a slight difference in the way you use these 2 different versions of volatility. The commands, they are like slightly different. So I will be mostly using volatility 2 for this class. But if you end up using volatility 3, just go to their website and they have like complete guides on how to use it and what are the equivalents of, plugin in volatility 1 and volatility 2. So here's like, an image of, or say, you can say a demo of the volatility. So here you have the tool name volatility. This is like from Kali Linux. So just after downloading the volatility, go into the folder that is that contains the volatility executable. Then type volatility. This -f tells which file we are going to analyze, then give the name of the memory dump or the RAM dump that you are trying to investigate. And then the first thing you need to do, like, or say the first plugin that you will be using for every memory analysis, is to determine the profile or the operating system that might have been used on the machine from which you acquired this memory dump. So for example, if you acquired the memory dump, say from Windows XP machine or Windows Vista machine or Windows 10 machine or a Linux machine, or say a Windows Server version, so on, right? So why we need that? Because volatility tries to carve the data depending on the information it has. So when it looks into the profile of the image or the memory dump, it figures out, okay, if it is a Windows XP machine, assume, then every process data structure will start with the key or with the byte sequence of 0 1 0 0 0 1 0 0. So when it is carving the data, every time it sees 0 1 0 0 0 1 0 0, it knows that this is a start of the process data structure. So in order to find the different data structures, or in order to carve different data structures out of the memory, it is very important that we know their signatures. And the way to find their signatures is if we know their profile, that which operating system this particular image belongs to. If we know that, we can use that information to carve the data successfully. So here I have like just done like the FTK imager that you guys used, or like you can find some the images that you created from FTK imager, or you can use like download images from the internet as well, memory images. Just run this image info and it will give you the suggested profile. So this is telling that this memory dump might be taken from a computer that will be running Windows XP. That's the first guess. The next guess is Windows XP as server 3, SPS3, and so on. So whatever, you just need to remember this, like not remember, just run this plugin and just copy paste this thing, like Win XP, whatever the first suggestion is, then we will be using this information later on. So once we run this image info scan, next we can start, running different volatility plugins. The way to do that is you say volatility -f, name of the file, the memory dump that you want to, investigate. And then this is the addition, the profile that we discovered with the last step. We will put it here, say minus profile is equal to win xp sps3 86. So this is the whole profile. And then we want to run this plugin, which is ps3. So ps3 will give us like a complete information of all the different processes that were running when this memory was captured. So you can see like all the each of these processes, they have a process ID called the PID. They also have a parent process ID. So as I mentioned or gave you the example of Google Chrome, that you start the Google Chrome, and then for each tab or for some multiple other services that are running on Google Chrome, it will Google Chrome itself will start some multiple processes in your computer. So the process parent ID is the ID of the process that started this particular process. So system is the basic program that runs. So whenever you start the machine, system process will run. You see its parent ID is 0. That means there is no parent for system. Then system created this process smss.exe. So you can see this is the PID of this process, which is 360, and it is created by systems. So system is its parent, right? Similarly, you can see all the handles, all the threads that this process is running, the time at which this process was launched, and so on. So there are so many other, like plugins as well that you guys will be exploring in your lab 3. So this was just like, I give you guys a basic demo, or just to show you guys like how the volatility or how this is internals or strings look like. If you have any question about, this lecture, please feel free to let me know. Just email me or message me on Blackboard, and I will try to get back to you as soon as possible.